All right, welcome back. And this is the O level 24 physics essay question, which is the question number 7. Let us look at how we are going to complete this question step by step. First, a student mass 40 kilogram staying at a lower level in the school premises climbs a flight of steps of 1.5-meter vertical height and enters a building at a high level. So this introduction gives us two important data, which is that the student's mass is 40 kilogram and the vertical height of the steps is 1.5 meters. Problem number 1. How much is the increase in potential energy of the student who reached the high level from the lower level? So they are asking when the student is there in the lower level and then he has gone to higher level, what is the potential energy difference that has occurred in this period? So we all know that when it's in the lower level, the distance is zero, the height is zero, therefore the potential energy in the lower level is zero. So we had to calculate the potential energy at the higher level to find out, to solve the Roman number 1. So we know the potential energy formula, which is mgh, mass, gravitational acceleration, height. So mass of the student is given in the introduction as 40 kilogram and gravitational acceleration is 10 ms minus 2. Height is 1.5 meter. So you get the the potential energy as 600 joules. Potential energy is 600 joules. This is exactly how you have to answer Roman number 1. Then Roman number 2. How much is the amount of work done by the student here? There's an easy way. You can simply write 600 joules here. But this is not a video to simply write the answer. I'll tell you how you can get that. Okay. We all know that work done equals force into distance, right? Force into distance. Also, we know that force is mass into acceleration, which is ma. So we can plug this ma in this. So we get work done equals ma into distance which is 1.5 meters. All right. Then we know the mass, which is 40 kilogram. Acceleration. Now, what's the acceleration? When climbing a stair, obviously the acceleration on the student would be the gravitational acceleration, which is pulling him down. So, acceleration here is the gravitational acceleration g, which is given as 10, and the height distance is 1.5 meters. So again, the answer here is 600 joules. So the work done by the student, as asked in the Roman number 2, is 600 joules. Okay. In Roman number 3, it asks, if the student took 4 seconds to climb the steps, what is the power of the student in climbing the steps? Very simple question. We all know the power equation, which is power equals work over time. What is the work done here? 600 joules. What is the time? It is 4 seconds. So what's the power? 150 watts or 150 joules per second. This is the power. Okay, so this is how you have to answer for the part A of the 7th question. Let me clear this down so that we can answer for part 2. So part B. It is a uniform block of mass 1 kilogram. A uniform block of mass 1 kilogram is kept at rest on a rough horizontal table as shown in the figure. Under how many forces does the wooden block stay at equilibrium? This is an easy question, but for overthinkers, it makes it complicated. Why? Because it tells the object is on a rough surface. Rough surface. We know that when the object is in a rough surface, when the object moves, let's say it moves to the right side, we know that there will be a friction to the left side. We know that, let me mark it clearly. When the object moves to the right side, we know that there will be a friction to the left side. But in this question, are they telling that the object is moving? No. They are telling that the object is at rest. So therefore, there is no friction in this case. Either. So in that case, what are the only two forces acting on the how many forces are acting on the wooden block to stay in equilibrium? Obviously, force number one is the weight. Okay, and after if weight is acting, obviously to stay in equilibrium, there would be a normal reaction. So under how many forces does the wooden block stay at equilibrium? Two forces. Okay, and name what those forces are. So you can simply tell, name what those two forces are: weight and normal reaction. C, part C. Copy figure 1 above in your answer script and mark those forces in it. I'm not going to copy, but okay, let me just try to copy it. Okay, so I have the figure 1 here. The forces acting, you have to mark the forces. You can mark the weight. You can mark the weight from the center. And then you can mark the normal reaction as well. Okay, so part D. What is the magnitude of each of those forces? Now, after doing to this much extent, some students forget that they gave a data called mass is 1 kilogram. So when the mass is 1 kilogram, can't we find the weight? Weight is equals mg, no? Mass is 1, g is 10, so weight is 10 Newton. If the weight is 10 Newton, the normal reaction would be obviously 10 Newton because the object is at rest or in equilibrium. So weight is 10 Newton. A normal reaction is 10 Newton. Okay, right. Next telling another identical wooden block is kept on the above wooden block as shown in the figure 2. Of the instances shown in figure 1 and 2, in which instance is the limiting force between the surface of the table and the wooden block greater? Now think like this. Let's say you have a very rough table, or let's say you're in the road. You're in the main road where the road is like not proper, it's a rough surface. You're in the road and you're keeping a heavy 10 kilogram box on the road. Okay, and it's at rest. You're pushing it, you're trying to push it. Okay, there's a friction. You know that there's friction, static friction, limiting friction, and dynamic friction. So you're trying to push it. It has a friction. Now, on that 10 kilogram box, you keep another 10 kilogram box and then you try to push it. Let's say the instance where you have the 10 kilogram object at the first time is instance 1, and you have two 10 kilogram objects, instance 2. What would be harder? Obviously, when you have two boxes, 20 kilogram, you think it's harder. Yes, actually, the limiting friction in that case is harder, greater. Okay, so you can tell with that simple logic, you can tell that figure 2, okay? Figure 2 has the greater limiting frictional force. So for that step, you can tell figure 2 කියලා you can shape එක manage it. Okay, then they're asking, explain the reason for your answer in part 2a. Explain why are you telling it's figure 2 කියලා they're asking. How will you explain? You can basically tell that friction is directly proportional to the result, normal reaction. Okay, friction is directly proportional to the normal reaction. In instance 1, you had, let me draw it properly. In instance 1, you had the normal reaction 10 Newton. In instance 2, you had the normal reaction 20 Newton. So if normal reaction increases, if normal reaction increases, friction will also increase. Also, if normal reaction reduces, friction reduces. So you can tell that. Explain the reason for your answer for part 2 above, because the normal reaction is higher than figure 1. You can tell. Forget this explanation here. This is just an explanation. Your answer you can tell, because the normal reaction in figure 2 is greater than that of figure 1. This is exactly how you have to answer for your part B, and then you get full marks. No points missed. You get full marks. Okay. So let's move to part C. Let me quickly clear this up. Part C tells AC and CB in the figure are two rectilinear straight line roads. Their lengths are 220 meter and 500 meter respectively. The shortest distance between the places A and B is 600 meter. A motor car starts from a state of rest at A, moves along the roads AC and CB, and comes to rest at B. It took 120 seconds for this motion. Taking the motion of car into consideration, calculate the following. The car is starting from this A. The car is starting from this A, going to C, then from C, it's coming to B, and it's taking 120 seconds to do this job. Okay, so first they're asking the distance traveled by the car. Now, think wisely, think properly. This is the distance. This is the displacement. This is a very easy question. If you can't answer this, probably you are cooked in your science paper. Okay, this is the displacement because it's the shortest distance between 2 points, and the car is traveling in a longer distance. Hurry. So they're asking for the distance traveled by the car, which is 500 meter plus 220 meter equals 720 meter. Average speed of the car. They are not asking for the average velocity. They are asking for the average speed. So average speed is total distance divided by total time. Okay, not total displacement, total distance. So what's the total distance? 720 meter divided by total time 120 seconds, which is 6 meter per second. Hurry. So then they're asking the displacement of the car. You don't have to do any workings. Simply they have given easily 600 meter here. One shot 600 meter. Now they are asking for the average velocity of the car. Average velocity. Average velocity is total displacement. Displacement divided by time. So what's the displacement? You only wrote in with your hands in Roman number 3, which is 600 divided by 120, which is 5 meter per second. See how simple the question was. Easily you could get 20 marks in your part 2 paper, which is 10 marks contribution to your final paper. So practice some questions like this. We will also upload more videos and some questions in the community. Make sure to try those, watch these reviews, and sharpen your skills on writing the paper. See you all in another video.